Okay, how are you everybody who is watching this video? I would like to take this opportunity to welcome you into a very interesting moment of learning about higher engineering and scientific mathematics. Welcome into our online institution that's called Tanzania Online Institute of Technology. We are in departments of higher engineering and scientific mathematics. We have a number of departments. This is the one of the departments. Then the course or the modules is called the Advanced Engineering Mathematics or Advanced Calculus. And we are in chapter 3 that's called the Partial Differential Equation, PDE. And the concept that you are going to learn in lecture 2, it's linear and nonlinear partial differential equation. This is the very interesting modules and very interesting topic. I say that it's the longest topic compared to other topics. It's a kind of the difficulty topics. It contains long questions and even a little bit challenging concept. I'll try my level best because I've been teaching this topic for more than 7 years. So I will try my level best to teach you by using different and simplest approach so that you can enjoy. And in these departments, we are teaching engineers. I am engineer, electronics and telecommunication engineer, but also I love mathematics. And I like to teach mathematics. I've been teaching mathematics for more than 15 years. So it's a job of my heart, or it's a work of my heart. So I would like to ask you that, be engaged in this class and be a serious student, ask the questions, and try your level best to make sure that you adapt the concept. So let us, before we start lecture 2, let us do the quick review of what we've covered in lecture 1. Just to link what we've covered in lecture 1. So the quick review of lecture 1. This is all about partial differential equation. In short, we call it PDE. So in lecture 1, mainly we have been focused on the terminologies. So the concept that we have learned is called the terminologies. Terminologies of what? Of partial differential equation. And the first terminology is the definition. What the means of partial differential equation? That's the first terminology. And then after that, I taught you notation of this partial differential equation. And we defined that the partial differential equation, this is an equation which containing containing dependent and independent variable, and also it contains partial derivative which is being differentiated or partial derivatives whereby dependent function variables depend 2 or more than 2 independent variables. So that's the definitions of partial differential equation. I taught you 3 notations of partial differential equation. So 3 notations I taught you. Then after that, the second terminology is what? Independent. So I taught you about independent and the dependent. So independent and the dependent variable. Very important, because today we are going to discuss about dependent variable again. And we define dependent variable is any variable which does not depend any other variable. While dependent variables is the variable that depend independent variables. In case of the partial differential equation, means dependent variables depends on two or more than two independent variables. And then the third terminology that we have discussed is called the we discussed about dimensions of partial differential equation. And define the dimension of the partial differential equation is the measure of number of independent variables present in a given partial differential equation. The first terminology is called the order of partial differential equation, and we define the meanings of order. We say that the order of partial differential equation, we say that this is the highest partial derivative present in the given partial differential equation. Then the last terminology is called the degree of partial differential equation. So today we are going to discuss about linear partial differential equation and non-linear partial differential equation. To reinforce the concept, I ask you to pronounce, say linear partial differential equation. And then say non-linear partial differential equation. So this is other terminologies. We'll be focused on linear, but linear itself, linear partial differential equation, it's a terminology. So you can start that this is all about today's lecture, and this is number 6. Linear, so this is in case of terminology is number 6, but in case of the concept, it's a linear partial differential equation. Very important, because in undergraduate level, we teach students linear partial differential equation. But in postgraduate studies, masters and PhD, we teach students about non-linear partial differential equation. So this is the very important concept to be understood. PD is abbreviations of what? Partial differential equation. So linear partial differential equation. Then, now let us define what is it. So what is linear? Before just learning about the condition for the partial differential equation to be linear, what is linear partial differential equation? How do we define it? That's a very important question. So a linear partial differential equation is an equation that involving partial derivatives in which the dependent variable and all the partial derivatives appearing in the partial differential equation are raised to the first power. So simply we say that a linear partial differential equation is an equation. So this is an equation. So this is an equation which containing, it's an equation involving or containing or involving partial derivative, which contains or involves what? Involves partial derivatives. Involves partial derivatives. Involves partial derivatives. Involves partial derivatives. So when we talk about partial derivatives, I taught you in previous lecture. Partial derivatives. So this is an equation that involves partial derivatives in which dependent variable, which is single, if you do remember, in which dependent variable and all partial derivatives. All partial derivatives present in the given appearing present, all the partial derivatives present in the given partial differential equation are raised by, so these are raised by first power. by first power. So this is the simple definition of linear partial differential equation. Say linear partial differential equation. Simply separating is an equation. This is one of the keywords. First of all, it's an equation. It's an equation which contains partial derivatives, different partial derivatives, either one partial derivatives or two partial derivatives or three partial derivatives, etc., etc. In which these partial derivatives, or in this linear differential equation, we say that dependent variable, which I taught you in previous lecture, lecture 1, and all partial derivatives present in that given partial differential equation are raised by first power. What does it mean? Listen, this is very important. We say that according to this definition, first of all, the characteristics of linear partial differential equation, it is this one. Dependent variable is raised by first power or by 1. So any dependent variable will have a power of 1. Any dependent variable present will have a power of 40 of 1. The second condition is that all partial derivatives, so all partial derivatives present in the differential equations are raised by what? By 1. So if these two conditions has been satisfied, however, there is another third condition, but if these two conditions have been satisfied, then that partial differential equation is called linear. Otherwise, it's a non-linear. Before I teach you examples of linear partial differential equation, let me teach you the 7th terminology that is non-linear partial differential equation. After that, I will teach you 3 conditions that we are using to decide whether the partial differential equation is linear or non-linear. Let me repeat. Listen. Before I give you examples of linear partial differential equation, let me teach you the 7th terminology, non-linear partial differential equation. After that, I will teach you 3 conditions that we are using to decide whether the given partial differential equation is linear or non-linear. And after that, I will give you more than 5 examples. And then so we'll be just using the condition to state whether the given partial differential equation is linear or non-linear. So right now, the next terminology, if there's no any question, it's what? Non-linear. So this is number 7. So let us learn about non-linear partial differential equation. And we have the very important question. What is non-linear? What is non-linear partial differential equation? What is non-linear partial differential equation? So simply, a non-linear partial differential equation, we say that is an equation. So this is an equation involving partial derivatives, in which the dependent variable and all partial derivatives and all partial derivative appearing in the given partial differential equation are raised to more than 50 power. More than 50 power. So a non-linear partial differential equation, we say this is an equation, one of the keywords, involving partial derivatives, in which the dependent variable and all partial derivatives appearing in the given partial differential equation are raised to more than 50 power. To more than 50 power. While for the linear, it means that the condition, all the dependent variable, it means that the dependent and all the partial derivatives must be raised by 1. While for this one, for the nonlinear, must be raised by either 2 or 3 or 4 or 5. Any other number rather than 1. Are we together? So those that's all about definition of of linear and non-linear. So if you have a question, you may ask. If you don't have a question, then let us learn 3 conditions that we are using to make decision whether the given partial differential equation is linear or non-linear. So simply 3 conditions for a partial, for a linear, 3 conditions for a linear, 3 conditions for a linear partial differential equation. So we say that in order for the given partial differential equation to be linear, then it must obey all the 3 conditions. All the 3 conditions of what? Of linearity. So you say that in order for the given partial differential equation to be linear, then it must obey the following, means all the 3 conditions of linearity. So simply the followings are the following. So I will give you each condition. The following are the 3 conditions for the partial differential equation to be linear. To be what? To be linear. The first condition, we say that the power of any dependent variable so the power of any dependent, in most cases we have only one dependent variable, of any dependent variable present in the partial differential equation must be 1. So for the partial differential equation to be linear, the first condition, the power of a dependent variable must be 1. Otherwise, it is a non-linear partial differential equation. What do we mean? Say otherwise. Means otherwise, if a partial differential equation does not obey this condition, that a dependent variable present the given has a power 40, power 41. Otherwise, the given partial differential equation is non-linear. Otherwise, it is non-linear. Non-linear what? Non-linear partial differential equation. Examples. Let us see. Let us see examples with a key focus of the first condition. We ignore about other conditions. So for example, we have u plus a sine of xy, then uxy, uxy, and then this one is equal to e power x. So, is this partial differential equation linear or non-linear? Stop writing. It is partial differential equation linear or non-linear based on this condition, right? So, first of all, how many dependent variables do we have there? One. In the given differential equation, we have only one dependent variable, which is u. Then, is this dependent variable? Yes. What is this one? Sin xy. This is the coefficient. What is uxy? This is the second derivatives of y, of u with respect to x with respect to y. And hence is equal to e power x. So this is the function. So if that's the case, so it means in this term and this term and this term, how many dependent variables do we have at the term? Only one, which is u. What the power of u? 1. So if the power of u is 1, according to this condition, then we say that the given partial differential equation is linear. So power is what? 1. So simply say that power of dependent variable u in given partial differential equation is what? 1. Therefore, the given partial differential equation is linear. Linear what? Partial differential equation. Second example. So this is example 1. Second example. So example 2, we say that we have this one. Partial derivatives of z with respect to x plus log of x, then second derivatives of u with respect to x with respect to t, then is equal to e power x z. Okay? So this is the partial differential equation. It's a given partial differential equation. So example, this one is said that given the PDE below, state if it is linear or non-linear. So you have to analyze the given partial differential equation. What is this? Partial derivative. What is this? Coefficient, which is it's a function. What is this? Second partial derivatives. What is this? It's a function. Then we don't bother about the power of the partial derivative or whatever. Our focus, do we have any dependent variable as a term? First of all, what are the dependent variables in this equation? Dependent variable. It is Z. Sorry, so here. You didn't ask me. So Z, it's our dependent variable. So you have only one dependent variable. Well, do you have a dependent variable at the term? Yeah. Do you have a dependent variable at the term? Dependent. Je, tuna term ambayo ndani yake ina dependent variable? Tunayo. Kumbuka hapa tulisema hivi, tulivyopewa hii ni dependent variable, ndio term yenye dependent variable. Hii ni coefficient ya second derivative ya u with respect to x and y. Hii ni function. Tukija hapa lazima pia tuangalie kitu cha namna hiyo. Tumeona kwamba z ndio dependent yetu. Hatuhusiki hapa na independent. Sasa je, tunaangalia kuna term kati ya hii na hii ambayo ndani yake kuna dependent variable? Ambayo ndio ipi? Ya kwanza ya hii. No, hii sio dependent variable. Hii ni partial derivative. Na hii ni partial derivative. Dependent variable ni hii hapa. Kwa term yenye dependent variable ndo hii. So this is the first partial derivative, this is the coefficient function, this is the second partial derivative. And then this one, this e power x, it's a coefficient of 40 of dependent variable z. So there it's the one that we call dependent variable. Then next check what the power of z present in this differential equation is 1. So the power of dependent variable is 1. It is obey this condition. The power of any dependent variable present in the given partial differential equation must be 1 in order for it to be what? Linear. So I say that so the power of dependent variable and the dependent variable for this case z is 1. Therefore we say that the given linear differential equation, it is what? Linear partial differential equation. Example 3 and last one for this condition. Given the partial differential equation, state if it is linear or non-linear. Hello, it's not the time for chatting. So the given partial differential equation is this one. So this is the given function, given partial differential equation, not function. It's a given partial differential equation. How many terms does it have? First, second, third, fourth. Okay? Then what is dependent variable for this equation? No? Yes, it is V. Then what are the independent variables for this partial differential equation? and y. Very good. Then the next equation. Do you have partial derivatives? Yes. Partial derivatives, partial derivatives, partial derivatives. What is this one? What is the coefficient of this partial derivative? 1. What is the coefficient of this partial derivative? V squared. What is the coefficient of e power x? So okay, so this is the function e power x. So this is the coefficient of second derivative of v with respect to y. Then ln of v, ln of x, y, v. So, how many dependent variables do you have in that equation? Yes. One. As a term, how many terms that we have that have the dependent variable? 2. The first one, the second one. Right? So in this term, v it's a coefficient. What the highest power of v? 2. What the highest power of this v? 1. So the power of v, the power of this one is 2. The power of that one is 1. The highest power between 2 and 1 is 2. So it means that the power, so we say that for this case, we say that the power of dependent variable what v? Power of dependent variable v is, it's what? 2. The highest power, sorry. The highest power. The highest power. It's what? 2. Remember that from the condition. The power of any dependent variable present in the given differential equation must be 1. Otherwise, the given partial differential equation is nonlinear. So is that linear partial differential equation or nonlinear? Nonlinear. So then we say that it is non-linear partial differential equation. So now, okay, fine. Now let us discuss the second condition. Condition number 2. So the power of any partial derivative present, so the second condition, the partial differential equation is linear if the power of any partial derivative present in the given partial differential equation is, so you say the power of any partial derivative present in the given partial differential equation must be 1. Must be what? 1. So remember that the adjective here or the keyword is partial derivative. We are not talking anymore about dependent variable for this condition. It's talk about what? Partial derivative. In the given partial differential equation must be what? 1. Right? Otherwise, if this condition is not obeyed, otherwise, the given partial differential equation is non-linear. So if the power of any partial derivative, whether highest partial derivatives or none or just any other partial derivatives, is greater than 1, maybe it is 2 or it is 3 or it is 4, that is non-linear partial differential equation. That's all. Kwa tunaangalia nini? Tunaangalia kwamba kipeo, kama kipeo cha partial derivative yoyote ile, iwe labda ambaye ni ya first derivative ya second au ya third, ni zaidi ya 1, inakuwa non-linear. Ikiwa 1, kwa hiyo inachotakiwa kwamba partial derivative zote ambazo ziko kwenye differential equations iwe 1, ziwe 2, ziwe 3, ziwe 4, ziwe 5, kipeo chake kinatakiwa kuwa moja. Sawa? Example 1. This will be example 4. Sababu we ended example 3. So state if the given partial differential equation is linear or non-linear. So what is that partial differential equation? So you say that this one, partial derivative of u with respect to x with respect to y, then plus sinh of x, then you have what? U is equal to first derivatives with respect to u with respect to x. So this is 3. You got that one. Solution. Separating. Let us solve. So remember the second condition talks about partial derivative. Say partial derivative. How many terms do we have here? 3 terms. First term, second term, third term. How many partial derivatives do you have? 2. 1, 2. What is this one? This is the function. Right? Then what the highest power of this first derivative? 1. Why do we say 1? We say 1 because its power, it's 1. This is the order. Then, what the second partial derivative is this one. What its power? 1. So it means that the power of all partial derivatives present in that partial differential equation is 1. Therefore, the given partial differential equation is linear. But remember the first condition. Do you have any dependent variable? Yes. Which is what? U. What the power of u? 1. Did this obey the first condition? Yes. Narudia kwa Kiswahili kwa sababu manake na kundi kubwa sana naitwa result oriented company. Narudia tena. Tunasema hili ndio swali letu kwa tumepewa. Tuna term 3. Ya kwanza, ya pili, ya tatu. Hii ndio yenye derivative, manake yenye mwinuko. Naita sababu nasema kwamba naita manake derivative au gradients, naita manake ni mwinuko. Sawa? Au naita slope. Kwa hiyo kuna hii na kuna hii term. Tunaachana na hii kwanza. Tunaangalia kwanza second condition kabla kuangalia first condition. Tumeambiwaje hapa kwamba kipeo cha pili cha partial derivative yoyote ambayo ipo inatakiwa kuwa moja ili iwe linear. Kwa tunaangalia hapa kipeo chake ni moja. Na hapa kipeo chake ni moja. Kama ndio hivyo, kwa kama kipeo cha hapa ni moja na hapa ni moja, imeheshimu sharti la pili. Sawa? Tunarudi sharti la kwanza. Kwenye sharti la kwanza tunaambia the power of any dependent variable present in the partial differential equation must be 1. Tunakuja hapa. Hii term ina dependent variable ambayo ni u. Sawa? Power yake ni nini? 1. Kwa hiyo imeobey condition zote mbili ambazo nimeshakufundisha. Kwa misingi hiyo sasa, hii tunasema kwamba nini? Kwa tukiangalia hii second condition nasema kwamba the power of each partial derivative. The power of each partial derivative. The power of each partial derivative is 1. Therefore, the given partial differential equation, it is what? Linear. It is linear partial differential equation. Example 5. So state if the given partial differential equation below is linear or non-linear. So what's that partial differential equation? It's this one. Partial derivative of v with respect to t. Then we have what? Square plus a power x. Then we have our second derivative of v with respect to t with respect to x. Then this one is equal to cos of x. Cos of x. Then we say that partial derivatives of u with respect to x squared. Let us solve. Solution. First of all, stop writing. How many terms do we have? 3 terms. First term, second term, third term. Right? Then, what is the first condition for the given partial differential equation to be linear? The first condition. The first condition. That's the second condition. Very good. But that's the second condition. The first condition, the power of any dependent variable present, if it is present, in the given partial differential equation must be 1. Kipeo cha pili au bana kipeo cha dependent variable yote au tunasema kwamba herufi inayotegemea herufi zingine inatakiwa kuwa 1. Je, kuna temu yoyote ambayo au kuna mkusanyiko wa herufi yote ambayo ndani yake kuna dependent variable? Iko wapi? Tukisema temu ambayo ndani yake kuna dependent variable, manake ni temu ambayo mara nyingi unakuja kukuta kwamba coefficient, manake dependent ndio inasimama kama function. Hatuna partial derivative. Ukiangalia kwenye hizi terms zote tatu, tuna partial derivative, partial derivative, partial derivative. Na dependent yetu hapa, lazima ujue pia dependent yetu, sorry, this is not u, this is v. Dependent variable yetu hapa ni v. Kuna mahali umeona v ikiwa haingabidi differentiated? Hakuna. Kama hakuna, maana yake hiyo condition ya kwanza, kinachotakiwa kupimwa kwenye condition ya kwanza hakipo. Okay? Okay? Kama hakipo, maana yake una skip your first condition. We go for the second condition. So it means that there is no any term that contains dependent variable as a function. So if that's the case, we skip the first condition. We move to the second condition. The second condition said that the power of any partial derivative present in the given partial differential equation must be 1. So we have to check. How many partial derivatives you have? 1, 2, 3. What the power of this partial derivative? 2. What the power of this partial derivative? 1. What the power of this partial derivative? 1. So, is the power of of any partial derivatives equal to 1? Remember the condition. Did this partial differential equation obey the second condition? No. Why? Because this partial derivative has a power greater than 1. So this is the non-linear partial differential equation. So you say the power of the first partial derivative is 2. Then, or therefore, the given partial differential equation, it is non-linear partial differential equation. Why? Because the power of this partial derivative is 2. Regardless that the power of this one is 1 and the power of this one is 1. 1 times of 1 partial derivative's power is equal to 2. That's all. Is it clear? Eh? Okay. So if it's clear, then we say that let us move to the steady condition. Unit right? Unit right? Stop. The steady condition, it is that in order for a partial differential equation to be linear, then what do you say? We say that, what should we expect? There should be no there should be no any product between a dependent variable and the partial derivative present in the partial differential equation. So there should be no any product. Stop writing. There should be no any product between what dependent variable and what partial derivative present in the given partial differential equation. So the steady condition talks the product. Hatutarajii kuwa na zao la dependent variable na partial derivative. Otherwise, hiyo differential equation yote, partial differential equation yote itakuwa ni non-linear. Sawa? Yani hatarajii tuone kwamba partial derivative imezidishwa. Nadhani kuna mfano pia tulikosea. Hebu angalia mfano wa 3. Tatu. Kuna sehemu kuna v. Ngoja nifundishe hapa alafu tutaenda kusahisha hiyo. So you say otherwise, if there is a product, that the means of otherwise, right? Otherwise, the partial differential equation is what? Is non-linear. Example 1. Example 6. State if the given partial differential equation is linear. So d phi with respect to t with respect to x minus sine of x, then first of psi dt plus 2 power x, then we say that we have psi. This is equal to x squared. Okay, so remember that when we check for the steady condition, this partial differential equation must first obey the first condition, second condition, and then the third condition. So when you want to analyze if it is linear or non-linear, then what do you say? We say that we have to check for the first condition. What the first condition state? The first condition state that the power of dependent variable present in the partial differential equation must be 1. Let us check. Do you have any dependent variable which is what? Not x.
Dependent.
Yes.
Dependent variable.
Yeah. Psi. Very good. So psi is a dependent variable. How many terms do you have first of all? 4 terms. First, second, third, fourth. right? Again, if that's the case, so we have 4 terms. 4 terms. Here you have partial derivatives, no partial derivatives, no partial derivatives. And do we have a dependent variable? Yes, itself, psi. What the power of psi? 1. Did it obey the first condition? Yes. We go for the second condition. How does it state? The power of any partial derivative must be 1. So we have this partial derivative. What is power?
1.
We have these partial derivatives. What is power?
1.
Did it obey the second condition? Yes. Now the third one. The third condition, you say that there should be no any product between a dependent variable and partial derivative. So this is the partial derivative, this is the partial derivative, this is the dependent variable. What does it mean? It means that if we don't expect to have maybe psi times partial psi, let's say partial derivatives of t. This is the product. Dependent variable, partial derivative. Do we have that? No. So if you don't have, then we say what? Linear. So you say that there is no product. There's no product between what? Between dependent variable. Dependent variable, which is psi, and what? And partial derivative. And partial derivative. So this one may be like this one. So therefore we say that it is what? Linear. It is linear partial differential equation. All right? Okay. Is it clear? Example 7. State if the given partial differential equation is linear. So what the given partial differential equation? U of xx plus sin y u of xy plus or minus u of x y is equal to e power 2x. Separating solution. Remember that this one also he said that the solution. Separating. Let us check for the first condition. First of all, how many terms do we have? 4 terms. Wow. And then in these 4 terms, how many terms that have partial derivatives? 3. Very good. So 1, 2, 3. Good. So that's the function. Okay? So if that's the case, you say that, let us check the first condition. We don't expect to have what? The power of any dependent variable must be 1. Do you have dependent variable? We don't have here. We don't have here. We have here. What is power? 1. So it obeyed the first condition. The second condition. The power of any partial derivatives present in the partial differential equation must be 1. What the power for this partial derivative? 1. What the power for this one? What the power for this one? 1. So this is 1, this is 1, this is 1. So it obeyed the second condition. The third condition, we don't expect to have what? A product between what? Dependent variable and the partial derivative. Do we have something like that? Yes. Where is it? partial derivatives of u with respect to x, with respect to x, with respect to y. Or u times the 30 partial derivatives of u with respect to x, with respect to x, with respect to y. So, therefore, we say that this is the non-linear partial differential equation. Remember that a partial differential equation must obey all the three conditions. Otherwise, it's non-linear. Right? So you say that there is the product between what? Between dependent variable. There is a product between dependent variable and a what? Partial derivative. There's a product between dependent variable and partiality derivative. What's that product? U power 1 or u times u of x, y. Therefore, we say that it is what? It is non-linear partial differential equation. Is it clear? Yeah, so if it's clear, today I'll leave the homework. Previous questions I did not leave them. So let me leave the homework. Very interesting. This is the, listen, a special result-oriented company or result-oriented people. So these are the questions which have been asked in test 2 of 2014 at Dar es Salaam Institute of Technology. Question number 1, and it had 5 marks. So try your level best to answer the question. So homework. Any teacher who loves his or her students will leave the homework. So this is homework 1. And this will be example 8. Refer DIT test 2 of 2014, question 1. The question states that, question 1, yes, so question 1, the question states determine whether each of the following, partial differential equation. So partial differential equation, PDE, is non-linear or linear. Also determine, state the order of each given partial differential equation. Also, and name the dependent and name the dependent and the independent variable. So partial derivatives of u with respect to x plus 2 second partial derivatives of u with respect to x with respect to y plus second derivatives of u with respect to y is equal to 0. If you solve this, you'll have 2 marks. B, it is x squared plus y, then first derivative of t first derivative of z. This one, second derivative of t with respect to second derivatives of x plus second derivative of t with respect to y. Then c, we have psi, first derivative of psi with respect to x. This is equal to third derivative of psi with respect to y cubed. So 2 marks, 2 marks, 2 marks. Then d, it is second derivatives of y with second derivatives of t squared minus 4 second derivatives of y with respect to second derivatives of x. This one is equal to x squared. E, first derivatives of z with respect to t plus partial derivatives of z with respect to s. This one is equal to 1 over z squared. So I have left 5 questions. Try your level best to decide or to check if they are non-linear or linear. State the order. I have taught you in lecture 1. This is S. So state the order of each given partial differential equation. Name the dependent and independent variables. I taught you about dependent, and order in lecture 1. And I taught you linear and non-linear in lecture 2. So let me know. Did you understand? Did you understand what we've been discussing? So it's clear. Yeah. So if it's clear, I would like to take this opportunity to thank God to have given me a chance to teach you. And I would like to welcome you in the next lecture, which is lecture 3, where we learn another terminology which is called homogeneous partial differential equation and non-homogeneous partial differential equation. And then we'll be, first of all, we'll do correction for this question, and then we'll be solving some other questions, because at least that now we have learned almost 9 terminologies of differential equations. So we'll be practicing different questions, how I've been asked it, and especially for those adult students, I know that they are result oriented. They need just the materials to help them to understand and answer exams and get the marks, then keep on with daily life. So invite some other students, try your level best to be serious, register yourself onto our online school that's called TANZANIA Online Institute of Technology. It's the official YouTube channel. Then make sure that you register by just subscribing, and invite some people, share these contents with other BNG 23 students, BNG 24 students, BNG 25 students, 26 students, and BNG 28, 29, and even BNG 30, because this is the beauty of advanced engineering, mathematics, or advanced calculus. So if you have any question, don't hesitate to ask me in the comment section. Thank you very much. See you in the next lecture. Bye-bye.
Africa.